This torpedo appears to miss the ship on purpose, but the water beneath the keel is the target. No impact, no hole. For one deceptive moment, the ship can look completely untouched. Then the first invisible load arrives, a pressure pulse racing through dense seawater. A high-energy gas cavity expands below midships, displacing water and beginning to lift the hull. Seconds later, that motion reverses. Water rushes inward, and the same hull is driven downward. On the bridge, a reported miss becomes a vertical hammer before anyone understands what happened. To understand why, start with the question that decides everything. What does the weapon know? The old mental model is simple: a blind metal cylinder following one rigid line. Publicly described, modern heavyweight torpedoes can use acoustic sensing to search through the water. Sonar, guidance, propulsion, and fusing work together, but none guarantees a perfect result. The U.S. Navy publicly describes the Mark 48 as acoustic homing, with digital guidance and digital fusing. That lets the weapon update its course as the target's position and geometry change. And crucially, physical contact is optional. It can pass beneath the ship without touching steel. That position matters because the keel and hull girder form the ship's continuous structural spine. But there is no magical center point. Depth, timing, hull design, and sea conditions all matter. The weapon only has to enter a useful region beneath the hull, not strike its side. If this changes how you see a miss, subscribe, because now the water itself has to break the steel. At detonation, explosive energy becomes extremely hot, high-pressure gas in a fraction of a second. Water resists compression, so a brutal pressure front spreads across a broad area of hull. In air, blast energy can disperse. Underwater, the ocean couples more of it into steel. Plating flexes, frames react, and serious loading can begin before any visible hole exists. Shock reaches foundations, pumps, pipes, cable trays, and sensors throughout the ship. Damage may start as small failures: a leaking flange, loose connector, or disabled actuator. Outside, the only visible clue may be a white water column beside an apparently intact ship. Before punch 2, lock in one word: pressure or collapse. Which scares you more? Comment it, then watch the ocean move. The explosive gas forms a huge cavity, not a vacuum, but a pressurized pocket pushing water aside. The water displaced from midships is water that can no longer support the hull. Depending on depth and geometry, the gas cavity rises beneath the keel and pushes support away. The center lifts while the bow and stern remain supported and still carry their weight. Then pressure falls. The ocean accelerates inward, the cavity collapses, and support disappears. That violent reversal whips the hull from upward to downward load with almost no recovery time. If the load exceeds its strength, the ship can break. Can, not will. Timing decides the outcome.